Okay, Chapter 3, Recognizing and Identifying Hazardous Material. And we have a lot of objectives in this chapter. Define hazardous material and weapons of mass destruction. Identify the UN DOT hazard class as well as the primary hazards associated with each. Describe the differences between hazardous material incidences and other emergencies. Describe occupancies that may contain hazardous material, and describe some way you might detect the presence of a hazardous material release. Now notice this particular text goes over the objectives for the awareness level and the ops level, so some of them may be redundant. Describe the limitations of using your senses to detect the presence of hazardous material. Describe specific containers and container shapes that might indicate hazardous materials. Describe how to identify the product, owner, and emergency telephone number on a pipeline marker. Describe how to identify a placard, label, or other marking used to identify the presence of a hazardous material. Describe the NFPA 704 Hazard Identification System. Describe the safety data sheet in shipping papers. Describe how to identify criminal or terroristic activities involving chemical, biological, or radiological event. Describe how to identify an illicit laboratory and explosive and secondary devices. And the big one here, gang, how to use the emergency response guidebook. Our operation level objectives. Describe occupancies that may contain hazardous material. Describe specific containers and container shapes that might indicate hazardous materials. Describe shipping and storage vessels that could hold hazardous material. And describe various models of transportation used to transport hazardous materials. Describe how to identify the product, owner, and emergency telephone number on a pipeline marker. Describe how to identify information and its significance on a pesticide label or a radioactive material label. Describe the NFPA 704 Hazard Identification System. Describe the safety data sheet in shipping papers. Describe assistance provided through Chemtrek. Recognize the surrounding conditions to take note of during a hazardous material WMD incident survey. Describe ways to verify information obtained from a hazardous material incident survey. Describe how to identify criminal or terroristic activities involving chemical, biological, or radiological agents. Describe how to identify an illicit laboratory and explosive and secondary devices. Finally, our last set of objectives here. Identify corresponding U.S. DOT hazard class and divisions given the following: blood agent, biological agent, choking agent, irritant, nerve agent, radiologic material, vesculants, and again, using the emergency response guidebook. If you don't get anything out of this class, this is one thing that I hope that you do remember how to use, because this is your best source of information in the event of a hazardous material incident, is how to use that ERG book. Scene size up. This is especially important in your hazardous material instances. You need to train yourself to stop and pay attention to your surroundings. There is a difference between looking and seeing. Looking is pointing your eyes in the right direction. Seeing is taking in visual clues and piecing them together to come up with an idea or a solution. Hazardous material emergencies may be detected based on the following: information from a dispatcher, information from people on the scene, or your own knowledge of the response area. Initial and ongoing actions are guided or should be guided through or by your department standard operating procedures, your level of training, and the information gathering efforts at the scene. I find it fascinating that more than 4 billion tons of hazardous materials are shipped annually in the United States. It is possible to identify many common commodities by their identification system. And a good example of this are the placard signage and/or usage of other methods such as detection devices, eyewitnesses accounts, and things of that nature to identify the presence of the hazardous material. But when we're talking about these placards, and we'll go more into it, just have a look-see at what you're riding next to on the road or the interstate. You'll see these shipping containers with these placards on the side and these 3- and 4-digit numbers. By all means, use your ERG or go ahead and download the app. There's a link on the lessons page and start seeing what you're riding next to and think about what would happen if that particular vehicle overturned or wrecked right there in front of you. So let's make sure we clearly define again what a hazardous material is. I know we're beating a dead horse, but it is important. So a hazardous material is any substance or material capable of poisoning possessing an unreasonable risk to human health, safety, or the environment when transported in commerce, used incorrectly, or not properly contained or stored. Hazardous material, W&D instances, are different from other types of emergency. Again, they are generally moved more slowly. The specific chemical or material largely dictates what is going to happen on scene. And there are law enforcement aspects to consider as well. Occupancy and location. 2 good indicators of the possible presence of the hazardous material are the occupancy and the location. The material present at a particular location may already be known, and the environmental health and safety department of a large facility should be contacted for information on the hazardous materials. Your senses should be used with caution to avoid becoming contaminated or exposed. Sight and sound are typically the safest to use. Generally, the farther you are from an incident, the safer you'll be. Rather than, quote, leading with your nose, use binoculars for distance. You really don't want to go up and start sniffing something if you don't know what it is. It could have detrimental effects. And I definitely wouldn't try to taste it either. So a container is a vessel or receptacle that holds material. The type, size, and materials that the containers are made of often provide information on what might be stored inside them. So if we kind of have an idea of what containers are out there, you have a good idea of what could be in them in the event that you ever come across them in an area like, say, a road, interstate, or whatever the case may be. So learning containers is very important. A 55-gallon drum and compressed gas cylinders are found at almost every manufacturing facility. Cardboard drums store solids. Stainless steel containers may hold dangerous chemicals, and cold liquids are kept in thermo-like drawer containers. Bulk storage containers are large volume containers, and these are ones that have liquids greater than 119 gallons in them. The bulk packaging with net mass greater than 882 pounds also fall in this category, as well as gases greater than 100-pound water capacity. So examples of this would be fixed tanks, highway, cargo tanks, rail tanks, totes, and intermodal tanks. And of course, we'll see pictures of those here shortly. Secondary containment is an engineered method to control spills or release product in the main containment if the main containment vessel fails. Often surrounds a bulk storage container. And a good example of this is a series of short walls forming a catch basin around a 5,000 gallon vertical storage tank. Typically, this can hold entire the volume of the tank along with a percentage of water as well. Large volume horizontal tanks. Above ground storage tanks or underground storage tanks can be these large volume tanks. They have a capacity from a few hundred gallons to several million gallons. They are usually made of aluminum, steel, or plastic. They may be pressurized or non-pressurized and typically hold flammable or combustible materials such as gasoline, oil, or diesel fuel. Intermodal tanks are both shipping and storage vessels. They have a capacity to hold between 5,000 and 6,000 gallons of a liquid. They can be pressurized or non-pressurized. They can be used to ship and store gaseous substances that have been chilled until they liquefy, such as nitrogen and argon. A box steel framework surrounds an intermodal tank to facilitate stacking and shipping. Types of intermodal tanks available. You have an IM 101 portable tank, and this is known as a Type 1 internationally. It has a 6,300 gallon capacity and an internal working pressure between 25.4 and 100 psi. It carries mild, corrosive, food-grade products and flammable liquids. Next, you have an IM-102 portable tank. It has a 6,300 gallon capacity and an internal working pressure between 14.7 and 25.4 psi. And it primarily carries non-hazardous material, but also may carry flammable liquids and corrosives. Pressure intermodal tanks, known as IMO Type 5 internationally, hold high pressure vessels, and they have a working pressure between 100 and 600 psi. They commonly hold liquid compressed gas such as propane and butane. Cryogenic intermodal tanks, known as IMO Type 7 internationally, these are low pressure vessels but can be pressurized up to 600 psi, and they commonly hold your cryogenic materials. Tube modules. There are several high pressure tubes that are basically attached to a frame. They have a working pressure that can range as high as 5,000 psi. They commonly carry hydrogen and oxygen. Non-bulk storage vessels. These are all types of containers other than your bulk containers. They have a capacity of up to about 119 gallons. Drums. These are barrel-like containers that hold a variety of substances, from your corrosive flammable liquids to something as delicate or easy as food-grade material. They have closed-head drums that have a permanent cover over them with one or more of these bung holes or bung ports, and these are small openings that can be removed with a bung wrench. And basically, they're kind of like a screw with a special diamond hex-looking head that can open and close the drum. You also have open head drums that have a removable lid and fasteners to the drum with a ring, and usually you can see them because they'll snap on the side of the drum. Bags. These are commonly used to store solids and powders, such as cement powder, sands, pesticides, soda ash, slag, lime, etc. They are traditionally plastic, but they can be paper or plastic lined paper. They do have pesticide label requirements, such as product name, active ingredient, hazard statement, total amount of product in the container, manufacturer's name and address, EPA registration number, EPA establishment number. They're also going to have single words, such as danger and poison. It should have a general first aid treatment with a description, as well as directions for use. It'll have agricultural use requirements and precautionary statements such as no mixing or mixing directions and things of that nature. It should also have storage and disposal information, as well as a classification statement on who may use the product. Of course, it'll always have the keep out of reach of children label. And in Canada, it'll have a PCP number. Carboys. These can be made of glass, plastic, or steel. They have a capacity traditionally between 5 and 15 gallons. They are often placed in protective wooden, foam, fiberglass, or steel boxes. They can be used for some corrosives and other types of chemicals like nitric acid and sulfuric acid. Cylinders. These are used to store substances such as nitrogen, argon, helium, and oxygen. These are often high pressure type containers. They are uninsulated and they do hold the compressed gas cylinders. You can also have low pressure cryogenic containers, as seen here. Pond containers commonly hold compressed liquefied gases such as chlorine and sulfur dioxide. Some may hold refrigerant like fluorocarbon gases. They traditionally have a 2,000 pound capacity and they are 8 feet in length and 3 feet in diameter. Most have a pressure relief valve called a fusible plug. Intermediate bulk containers. The volume inside fall between what is typically found in drums or bags and cargo tanks. Capacities are usually greater than 119 gallons but less than 793 gallons. They can be flexible or rigid. Super sacks hold solid materials from 500 to several thousand pounds. They can have fabric rings from woven cloth to polyethylene. Totes hold a variety of substances. Capacities range from 119 to 793 gallons. They can be polyethylene or square metal tanks. It's important to note that hazardous material may be transported by air, sea, and land. Roadway transportation is the most common method of hazardous material transportation. It is important to become familiar with all types of the transport vehicles. Cargo tanks, as defined by 49 CFR 171.8 or local jurisdiction regulations. These have bulk packaging permanently attached to or forms a part of a vehicle. They can be separate from vehicle but unloaded without being removed from the vehicle. The Motor Coach 306. This is used for flammable liquids. The transportation liquids traditionally can be food-grade products, gasoline, or other flammable and combustible liquids. They hold between 6,000 to 10,000 gallons. This is a non-pressurized tank, and it should have a remote emergency shut-off valve. A good way to tell the difference between this and the other tanks that we'll see here shortly is to look at the egg-shaped back of the container. That helps identify it as a Motor Coach 306. Motor Coach 307. It has a capacity between 6,000 to 7,000 gallons. It transports flammable liquids, mild corrosives, and poisons. It can be insulated or uninsulated. If it is insulated, it'll have a horseshoe-looking shape. And if it's uninsulated, it'll have a round-looking shape. Again, looking at the back of the container will help dictate what type of motor coach it is. Also notice the railing is now on the side and not the back. The Motor Coach 312. It is smaller in diameter than the Motor Coach 306 and 406. It has a capacity of about 6,000 gallons, and it is geared to transport concentrated sulfuric acid, sodium hydroxide, and phosphoric acid. A good way to help identify it is these reinforcement bands along the side of the container, as well as this top walkway. The Motor Coach 331 pressure cargo tanker. It has a capacity between 1,000 to 11,000 gallons. It does transport things such as ammonia, propane, freon, and butane. It does have an explosive threat. It should have a spring-loaded relief valve, and it may explode if it's unable to keep up with rapidly burning material or internal pressures. Motor Coach 338 Cryogenic Tanker. It maintains a low temperature to transport cryogens. It is a low pressure tank. Often it will emit puffs of white vapor from the relief valve to maintain proper internal pressures. Operation of valves requires special training, and it can have explosion hazards if the valves are used improperly. Tube trailer. This is for high volume transport containers made of several cylinders banded together and affixed on a trailer. It transports such things as hydrogen, oxygen, helium, and methane. It has a working pressure between 3,000 and 5,000 psi. Dry bulk cargo tank. This is used to transport dry bulk goods such as powders, pellets, fertilizers, and grain. It is not pressured, but may use pressure to offload the product. Notice that it has V shapes in it with rounded sides that funnel content to the bottom mounted valves. Rail transportation. Almost 2 million railroad cars of freight are moved each year in the United States. It does have relatively few hazardous material incidents that occur. But some instances can create unique and significant hazards. Car type recognition is important to help determine the contents. Each type has a distinctive profile that can be recognized from a distance. Rail tank cars are usually labeled on both sides. revealing the car's owner, capacity, and specifications. Non-pressurized rail tank car has a capacity between 4,000 and 40,000 gallons. It is used to transport general industrial chemicals and such things as corn syrup, flammable and combustible liquids, mild corrosives. Newer cars have visible valves and piping. Pressurized rail tank cars. These are used to transport propane, ammonia, ethylene oxide, and chlorine. This has high volume contents that can generate long duration and high pressure leaks. Stopping leaks may require a special kit. Notice you can tell the difference by the rounded edges on the edge of the tank, as well as this flat, bolted in top cover. Special use rail tank cars. Cryogenic tank car is the most common. Hazards are specific to the particular rail car and its content. Pipelines. Pipelines are rarely involved in emergencies. Pipeline instances present a special challenge and require special trained responders. Transport natural gas, gasoline, and diesel fuel and other products come through pipelines. They are often buried underground, but may be above ground in remote areas. Pipeline right-of-way is an area, patch, or roadway that extend a certain number of feet on either side of the pipe itself. The pipeline owner maintains this area. They should have warning signs placed along the route of the pipeline. You may see vent pipes and inverted J-shaped tubes that provide pressure release. They should be clearly marked and contain information about the pipe's content and owner. Transportation and facility markings. Labels, placards, and other markings on buildings, packages, boxes, containers often make it possible to identify a released chemical. There are various marking systems that are in use. Department of Transportation marking systems. This uses labels, placards, and markings. It is used when materials are transported in the United States and Canada. Placards are diamond-shaped indicators placed on all four sides of the transport vehicle carrying the hazardous material. Labels are smaller diamonds placed on all four sides of boxes and smaller packages being transported. Certain hazardous substances may require markings only if a certain quantity is being transported. Other chemicals are so hazardous that shipments of any amount require the use of labels or placards. NFPA 704 marking system. This uses diamonds that are found on the outside of the buildings, on doorways to chemical storage areas, and on fixed storage tanks. The diamonds are broken down into 4 smaller diamonds with different colors, corresponding to different characteristics. The blue diamond at the 9 o'clock position has to do with health hazard. The top red diamond, flammability. The yellow diamond at the 3 o'clock position has to do with its reactivity. And the bottom diamond, white in nature, deals with special hazards, such as a burning O, which would mean oxidizing capabilities, or 3-bladed trifold looking fan, and that would indicate radioactive material. Hazardous Material Information Systems. This helps employers comply with OSHA Hazardous Communication Standards. It is similar to NFPA 704 marking system. It is meant for the employees at a facility. It gives necessary information to work safely around the chemical. It is not required by law. It is a voluntary system. It uses a numerical hazard rating, colored horizontal columns, letters, and icons to describe the hazards posed by a particular substance and provide guidance about choosing the proper protective equipment. The Hazardous Material Information System can give responders clues about the presence and nature of the hazardous material in the facility. Here's a good example. Military hazardous material and weapons of mass destruction markings. These mainly identify detonation, fires, and special hazards. It is divided into 4 categories based on relative detonation and fire hazards. Division 1 has mass detonation hazard. Division 2, explosion with fragment hazard. Division 3 is a mass fire hazard. Division 4 is a moderate fire hazard. Colors depict chemical hazards. Red identifies toxic agents. Yellow is harassing agents. And white is white phosphorus. Military shipments contain hazardous material WMD are not required, by exception, to be placarded. There are many reference books available to responders to use in hazardous material incidences. The main one that is used is the DOT Emergency Response Guidebook, often called ERG. It contains information on about 4,000 chemicals. It is helpful in deciding on preliminary actions to take. Responders should seek additional specifics about materials in question. They should also consult appropriate emergency response agencies. Use emergency response numbers on shipping documents if applicable. Now the ERG is divided into 4 basic sections, and you'll see in the lesson plan, or the lesson folder, ERG link to go to an electronic version, as well as some practice slides and things of that nature. And I do want you to be able to use this book effectively. You may have a quiz on it. Hint, 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 cough, cough, cough. So it is organized into 4 colored sections. The yellow section, chemicals are listed by their UN identification number. In the blue section, the chemical is listed alphabetically by name. The orange section is organized by guide number, and this has hazard class, fire explosion hazards, health hazards, and basic emergency actions. The green section is organized numerically, again by the UN ID number, and it provides your initial isolation distance. It also includes your water reactive materials that produce toxic gases, toxic inhalation hazards, and dangerous water reactive material. Essentially, in a nutshell, you're going to look up the chemical in the yellow or blue section, whether it be by name or number. Then that section will give you a guide number that corresponds to a section in the orange. And you'll go to that reference page and it'll give you generic preliminary actions to do for that type of chemical. Now, if that chemical is highlighted or in green, then you need to flip, and that's again from the blue or yellow section to the green section in the back to the corresponding ID number and read the particulars, because this is a very toxic substance and probably requires higher isolation distances. Other sources of information. Safety Data Sheet used to be called the MSDS, or Material Safety Data Sheet. This provides basic information about the chemical makeup of a substance, its potential hazards, and appropriate first aid treatment. Facilities that use or store the chemicals are required by law to have this sheet on file for each chemical. Shipping papers. Anytime the material goes anywhere, it is required to have shipping papers. On the shipping papers, it should have the name and address of the shipper and receiver. It should identify the material being shipped, as well as the quantity and weight. Called bills of lading or freight bills for the road and highway transportation should be located in the cab of the vehicle. Called way bills for rail transportation, they should be in each car on a train, and also has a list of content called a consist or train list. Called dangerous cargo manifest for marine vessels. This is kept in the wheelhouse and in the custody of the captain or master. In airplanes, it is called air bills for air transportation, and it should be kept in the cockpit in the custody of the pilot. Chemtrec, Chemical Transportation Emergency Center, can provide responders with technical chemical information via phone, fax, or other electronic media. They offer phone conferencing services, plus responders it puts responders in touch with shippers, as well as subject matter experts and chemical manufacturers. This is kind of your one-stop shopping for, hey, I've got an emergency, I really don't know what to do. So in your ERG book, you can find the number for Chemtrec located on the back cover or back page of the book. They do have a Canadian and Mexican equivalent. National Response Center, known as the NRC, must be notified when a significant hazard incident occurs. It is operated by the U.S. Coast Guard, central notification point rather than a guidance center. Potential terrorist incidences. Possibilities do exist in major metropolitan areas as well as in small towns. Any incident involving terrorism will require assistance and cooperation of many local, state, and federal resources. Responders should be familiar with the locations of potential targets in their areas, such as infrastructure targets, symbolic targets, and civilian targets. Chemical agents. Overt indicators of chemical agents can be chemical type gloves, chemical suits, respirators, and marked or unmarked containers made of various materials. Other identifiable signatures can be odor, liquids, or solid residue, dead insect, or foliage. Personnel may exhibit symptoms of exposures. Biological agents. Clues may include petri dishes, Bennett hoods, Bunsen burners, pipettes, microscopes, incubators, and microbiology or biology textbooks. Other clues can be metal cylindrical cans, red plastic bags or boxes, and plenty of personal protective equipment lying around. Personnel may exhibit symptoms of exposure. Radiological agents. Have a trivia question for you guys. Who is the largest shipper of radiological material in the United States? And the answer would be FedEx, due to the amount of medical radiological equipment that they ship worldwide. So, clues may include, for radiological agents, lead or stainless steel containers, detonators, radiologic protective suits, respirators, and Geiger counters. Personnel may exhibit exposure symptoms such as burns or difficulty breathing. Responders must be able to recognize potential situations where radioactive material might be encountered, such as food testing labs, hospitals, medical research centers, biotech facilities, construction sites, and medical laboratories. Radiological shipments require labels when being transported. They require a transport index, or a TI number, indicating the highest amount of radiation measured 1 meter away from the surface of the package. Radiological packaging. Accepted packaging is used to transport materials that meet only general design requirements for hazardous material package, and it's used to transport low-level radioactive substances. You're looking at something here probably like a cardboard box. Industrial packaging is used to transport low activity material and contaminated objects, and you have type A, type B, and type C. Type A is designed to protect the internal radiological contents during normal transportation and in the event of a minor accident. Type B is more durable than a Type A to prevent the release in the case of extreme accidents during transport. And Class C is for dangerous radioactive substances transported by air. It is not certified for use in the U.S. Illicit laboratories. Clues may include terrorist training manuals, basement locations with multiple vents, and buildings with heavy security or obscured windows. Drug laboratories are the most common type and use everyday items such as jars, bottles, glasses, cookware, and tubing. Explosives. Clues may include protective equipment, production and containment materials, explosive materials, reference materials as well. Secondary devices. A form of explosive or incendiary device designed to harm responders summoned to the scene for some other reason. Usually takes place as responders begin to treat victims of the initial attack. Indicators include timers, wires, switches, and concealment containers such as briefcases, backpacks, or propane tanks. Perpetrators may watch the site of the primary devices, preparing to manually activate the secondary device. Summary. Responders must interpret visual clues effectively to improve their ability to mitigate an incident. Responders should be able to recognize the various container profiles and understand the general classifications of material that may be stored inside each type of container. Responders should be able to name, understand, and locate the various types of shipping papers on various modes of transportation. Roadway vehicles often transport shipments from the rail station, airport, or dock to the point where the material will ultimately be used. For this reason, responders must become familiar with all types of chemical transport vehicles. When used correctly, various marking systems indicate the presence of hazardous material and provide clues about the substance. The DOT, NFPA, HMIS, and military have all developed marking systems specific to their level of response. Responders should be able to demonstrate proficiency when using the Emergency Response Guidebook. Responders should know how to obtain the SDS documents from various sources, including their own department, the scene of the incident itself, or the manufacturer of the material. Finally, responders should become familiar with the location of potential terrorist targets in their jurisdiction, the general and specific hazards of chemicals, biological, and radiological agents, indicators of illicit laboratories, and the basic operational guidelines for dealing with explosive events and identifying the possible indicators of secondary devices. Okay, gang, you have plenty of review questions to get knocked out for Chapter 3. If you have any questions, feel free to call me at 706-357-0162, or you can email me at aroberts@athenstech.edu. Until next time, be safe and have a wonderful day.